Yeah, so we know Tuakaso. What else do we know? We also know that tangent is a bit special. You can rewrite it as sine over cosine. Then now I'm going to introduce, then we also learned about using the ASTC and the quadrants. We are able to deduce the sine, cosine / tangent of any angle, right? Any angle. But sine, cosine, tangent is all based on what kind of triangle?
Right angle.
Right angle triangle, which means that you have to obey a certain theorem known as the Pythagoras theorem. So c squared equal to a squared plus b squared. So with that in mind, you realize that if there's a square, it means it will involve a square root, right? So that's why we have some special trigo angles and their corresponding values. In particular, when theta is equals to 30 degrees, 45 degrees, or 60 degrees. There is also, if you look up online, special identities involving 15 degrees and what's the other angle? 75 degrees. But we don't talk about that here. For Amax, you don't need that, but you need to know this tree. I think I already sent you the video, right? But basically for 30, 45 degrees, 30 degrees, 45 degrees, and 60 degrees, you can construct this triangle. Okay, sorry, no, you can construct this table. Let's say that you have theta here, and they take on different values: 30 degrees, 45 degrees, or 60 degrees. Okay. You can draw this table, and you realize that sine, cosine, and tangent, they take on certain patterns. Did I talk about this before? I can't remember. I feel like I drew this table before for you. No?
I'm not sure.
Okay, I'll just tell you the numbers first. Later, then I explain how I get those numbers. Okay, so what the first two rows, I'll just write a fraction over 2 over 2 over 2 over 2 over 2 and square root everywhere. Okay, that's a pattern. Then from 30 degrees to 45 degrees to 60 degrees, if you think about it, what happens as you take the sine of a larger and larger angle? Like imagine if you had a circle here. That's the center. Think about it. What happens to your sine? If this is 30 degrees, then this is 45 degrees, then that's 60 degrees. Opposite over hypotenuse. Opposite, the new opposite, is it longer or shorter?
Longer.
Opposite over hypotenuse. If you maintain the hypotenuse to always be the same, and they should be the same because it's a radius of a circle, you realize that the opposite length gets longer and longer, which means that you expect the sine theta value to also increase. Agree?
Okay.
So the pattern here is 1, 2, 3. These are the exact values of sine 30 degrees, sine 45 degrees, sine 60 degrees. How about for the other way around, cosine? You're looking at the adjacent,
Smaller.
Smaller, so it decreases. What's the pattern? Instead of 1, 2, 3, 3, 2, 1. Okay, that's how you remember it. And then remember that tangent is what? Tangent is what? Sine over cosine, right? We have sine here, we have cosine here for 30 degrees. So that means tangent 60 degrees, tangent 30 degrees must be sine 30 over cosine 60. Take this fraction, divide by this fraction. What do you end up with? Square root 1 over square root 3. I'll cancel away the 2, which means that it's really just 1 over square root 3. Because square root 1 is just 1. Okay? Then how about the other one? What do you think is tangent theta?
1.
Exactly, it's the same fraction, so divide, you get 1. This one?
Root 3.
Root 3. What's the pattern? Times root 3 times root 3. Does this pattern hold all the way? No, it's just a coincidence. Then it happens to be times root 3 times root 3. Not so important. Okay, now you have learned the mnemonic, like a table memorizing way of remembering this angles. Here is how you do it more naturally. What we usually start off with is first to identify this kind of triangle known as an equilateral triangle. Okay, where can you see equilateral triangles? You will see them inside a circle. Let me draw a circle. So let's say you have a center here. You draw two radiuses and you draw a line that connects them together. These are the radiuses of a circle. Okay, let's force the radius to be 2. Is that okay? Then what happens when you have this guy here? It's perpendicular and pass through the center. What does it do to this, what we call a chord? Perpendicular what of a chord?
Bisector.
Bisector means what? It means you cut into 2 equal halves. Here and there. Is that okay? So now we translate it to this triangle. We also cut it in half. We get 2 equal lengths. And since this is a what we call we started off with by assuming it's an equilateral triangle. So that means that all 3 sides have equal length. This, and this. Then that means we can do some special properties with it. Okay, maybe this circle, I'll just shrink it down. Not very relevant. I just need the triangle. If I force the length here, here, and here to be length 2, we have a perpendicular bisector, so it splits the length 2 at the bottom into half, right? I mean, into 1, 1. Agree so far?
Yeah.
Yes, Then by Pythagoras theorem, let me just draw it nicely. By Pythagoras theorem, you know that the perpendicular bisector, the perpendicular bisector will create a right-angled triangle, which means that you can now use what theorem? Pythagoras theorem. If you know the length 2 here, the length 1 here, can we find out the remaining length?
Yeah.
Of course, using Pythagoras theorem. So what is that length? It must be square root 3. Is that okay? Okay, good. So now that you know this is square root 3, we can also figure out its angles. This is what kind of triangle? Equilateral triangle. What's so special about equilateral triangle in terms of
60.
60 degrees for all of them. You got 90 here, you got 60 here, so the remaining must be 30 degrees. Okay, then from there, you can have this triangle. So zoom in on this triangle, you can construct your sine, cosine, and your sine and cosine only for 30 degrees and 45 degrees. Do you see how it's related? Let's say we try one. Let's say we try, I don't know, what's good? What's a good example? Sine 60 degrees. Okay. What would it be? Opposite over hypotenuse, right? So it will be square root 3 over 2. This is an exact angle, exact answer. Is that okay? Of course, if you type in a calculator, what will you get? Do you have your calculator with you?
You'll get some a lot of digits.
A lot of digits, right? I think you get 0.86602, so on. Right? So let's say that this is pretend that you're in an exam setting and you forgot how to get the exact value root 3 over 2. You forgot all this story.
Press square.
Yes, very good. Just square it. So you end up with sine square of 60 degrees. Notice that the square here, I put it in the middle. This is exactly the same as sine of 60 degrees, bracket, bracket, the entire thing, then square outside. It just happens that historical reasons, I also not sure why, but the square notation is appearing in the middle. It means the same as sine 60, bracket, bracket first, then you square the entire thing. Oh, they are the same notation. Is that clear? Sine square?
Yeah.
Okay, then using a calculator, you will get some squared value to be what, 3 over 4, right? Using a calculator. Then how do you recover the original sign? You just have to
root both.
Then you know how to deal with surds already. You're very good at surds. Square root top and bottom. So you get 3, 4. But what's square root of 4? Is just 2, right? Exact value. So you're left with square root 3 over 2. Then that's how you can recover it using a calculator. If you really forgot how to get the square root 3 over 2. Is that okay? Use a calculator to square first and then you manually square root. Calculator gives you 3/4. Square root, you do it manually, you split into 2 parts, and then you evaluate the bottom into a 2. The top remains as square root 3. Is that okay?
Yeah.
And Then you can do something similar with the cosine and sine. I will spare you the trouble, the bottom of doing it. You can try on your own. Like cosine square and cosine square and sine square, and maybe also tangent square. Okay, but one more angle I want to bring up is one more triangle I want to bring up is this isosceles right angled triangle. Okay, what do I mean by that? I mean I want to have a 90 degrees here, and I want these two lengths to be equal. So in that case, let's force this length here to be 1, 1. Okay. Then what will my hypotenuse length be? It will be, what is it?
It will be root 2.
Root 2, exactly. Yeah, square root 1 square plus 1 square. Okay, by Pythagoras theorem. So what will the angle here be?
45.
Very good. So that means that we can now construct our sine 45 degrees and cosine 45. Also, sine 45 is what? Opposite over hypotenuse. Right? Cosine 45, adjacent over hypotenuse. But you should realize that no matter which 45 degree you use, it will always give you 1 over root 2. How about tangent? Opposite over adjacent, right? So it's 1 over 1, which is just 1. Is this okay?
Yeah.
Clear so far? But wait,
Yeah.
how come? How come this one is root 2 over 2? You see? But here I put down 1 over root 2. That's when you need to recall your surds. I think I briefly mentioned before in the exponent and surds class in this course that you need to remember your surds. This is when you need to remember it now. You need to know that they are the same. Why? Because you can multiply top and bottom by square root of 2. So you're left with square root 2 over 2. Okay? Same thing with the cosine. Is this okay?
I don't know how I'm going to remember.
Rationalize the denominator. You can use a calculator. I mean, you're not even going for exam anyways. You can use a calculator if this is the easiest way. Square it with a calculator, then you manually square it. Square with a calculator, manually square it. Okay? How to remember? How do you study for exams? You sit down and you go and memorize. What else are you gonna do? Okay, anyways, that is something about these table of values. But I need you to notice another pattern. Can you tell me what's a pattern here and here? They are the
Same.
how about here and here? They are the
Same.
how about here and here?
Same.
Is it a coincidence? Let's summarize what we found out. Square root 1 over 2 is just 1 over 2. Also, in other words, a sine 30 degrees happens to be the same as cosine 60 degrees. We also got sine 45 degrees being square root 2 over 2, which is cosine 45 degrees. We also have cosine of 60 degrees. Oh, sorry, sine of 60 degrees. Follow the pattern. Sine of 60 degrees being square root 3 over 2, which is the same as cosine 30 degrees. What is the pattern you can see here?
I mean, it's just 90 minus the thingy.
Yes. Wow, how you know this pattern? Okay, very good, very good. Yes, basically the sum of these two angles is 90 degrees, right? Or in other words, one of them is the 90 minus of the other. In other words, in general, for sines and cosines, they will be related by this relationship. Sine of 90 degrees minus away theta equals to cosine of theta. Or you could also say sine of theta equals to cosine of 90 degrees minus theta. Okay? How do you prove this? You can just draw a triangle. If here is 90 degrees, here is theta, what will the other angle at the top be? It must be?
It must be 90 minus theta.
Then from there you can go and work out sine of 90 minus theta versus cosine of theta. Adjacent over hypotenuse, opposite over hypotenuse. You realize it's the same ratio. Likewise for this other guy. Okay? The basic, more generally, sine of angle A equals cosine of angle B, provided that if angle A plus B is equals to 90 degrees. Okay?
Okay.
Yeah, good. That is another general pattern. Maybe I should write it down somewhere. This is a star. This is a star. These three equivalent versions is also one ideal, a star. And there's another identity I need to talk about, which is the negative angle identity. Did you know that sine and tangent they follow this pattern? Sine of negative theta, tangent of negative theta is equal to sine of tangent of theta, but minus sine outside. Did you know this?
No, forget.
No, yeah. I actually it's not in Emacs. It's not in Emacs. It is only in Amax.
Okay.
Yeah, so it's new. It's new. Okay, it's new information. But for cosine, cosine in this case, if it's a negative theta, a bit different. You just leave it alone as cosine theta. Okay. How do you prove this? You can use the definition of the trigo in terms of a unit circle, the unit circle definition. So let's say that theta here, if we have negative 120 degrees, then I want to show that sine of negative 120 degrees is the same as negative times the sine of 120 degrees. So let's just do that on a circle. I'm trying to make it bigger. So where is my negative 120 degrees? Negative means you turn clockwise or anti-clockwise.
Clockwise.
Clockwise, So that means that I will start with the positive x-axis. I turn clockwise 120 degrees until I reach somewhere here. Okay, can. So I draw a line. I draw the curve negative 120. Then what is the sign? You just read off this intersection. It must be cosine negative 120 degrees, comma sine of negative 120 degrees. Okay, it's always cosine theta, comma sine theta. The theta in this case being negative 120. Is that okay? So in terms of the length, this y coordinate is sine of negative 120, which means that it's actually the what is it? The vertical length here, right? Maybe I'll use purple. This purple length here is sine of negative 120. All right, I'm assuming this is a unit circle, radius 1. Radius equal 1. So this is like x squared plus y squared equal to 1. Okay, you already learned equation of a circle. I'm sure you know this. Then how about the negative 1 times of sine 120? What is sine of 120 degrees? You just have to rotate along from the positive x-axis by how many degrees? 120 degrees. But here, 120, is it anti-clockwise or clockwise?
Wait, say again.
Okay, now I'm trying to show that I already got sine negative 120. It's this vertical length, but it's negative because it is below the x-axis. But now I want to show that this will be the same as negative of sine 120. Then my question is, how do I represent 120 degrees on the unit circle? I start with the positive x-axis and I rotate 120 degrees. But do I turn anti-clockwise or clockwise?
Anti-clockwise.
Very good. So positive angle, you go anti-clockwise. So that means you turn from here 120 degrees until you land here. Okay? So let's just draw that line. By symmetry, 120 here, 120 there, this guy will be equal. So these two lines are reflections. Okay? Just by symmetry. Okay, so positive 120 is there. Then that means that this coordinate here must be cosine of 120 degrees, comma sine of 120 degrees. Right? But what is sine of 120 degrees now? It is this vertical length here, is the y coordinate. What's the difference between sine 120 degrees versus sine negative 120? They are the same length, but in opposite direction, a bit like vector method, right? When you're solving coordinate geometry.
Mm.
Here, it's actually a value that can be negative, right? So that means sine 120, since it's above the x-axis, it is positive. This guy is negative. The only thing, but their length is the same. So what's your conclusion? Sine of 120 and sine of negative 120, they are equal, but you need to include an extra minus sign.
Yeah.
Negative sign, exactly. Okay, then you can do the same argument for all the other angles. And basically, this is your conclusion. For sine and for tangent, no matter what angle you try to play around with, you can go and do an experiment. What if theta equals to 30 degrees, theta equals to 150, theta equals to, I don't know, 200, theta equals to 280. Oh, basically quadrant 1 angle, quadrant 2, quadrant 3, and quadrant 4. You can use any other examples and convince yourself that these formulas work. Okay? But
Okay.
basically, negative inside the what we call the argument of the sign, you can take it out from the sign. So you end up, the negative ends up outside. For tangent, you do the same thing. The negative ends up outside. The tangent is now becomes tangent of theta, but you have an extra minus sign outside. But for cosine, cosine is a bit special. You don't need to take out, you cannot take out the negative sign. It just disappears. Cosine of negative theta is the same as cosine of theta. Maybe this one I try to do and this same long-winded experiment with you using a unit circle. Let's just try with one example. Cosine. Oh wait, actually I can just use the same diagram. Never mind. Cosine of, let's say theta is 120. So negative 120 versus cosine of 120. Let's see what it is. This guy here is what? This guy here is gray color. It's the x coordinate, right? So it's over here. This I mean the x coordinate is the same as this x value here. Which is sort of like this horizontal length here. But if you consider the green color cosine 120, you realize that you get the same length here. Right? Cosine is adjacent over hypotenuse. So adjacent green over the hypotenuse length 1. Since they are both in the same direction to the left of the y-axis, and they happen to be the same length, then that must mean they are the same. So that's why they are equal. Cosine negative 120 equals to cosine 120. Don't need to times negative 1. Is that clear?
Yeah.
Can yeah, so no negative sign. All right, these are the 3 identities you need to know. Oh, by the way, so far I've been using degree, but of course in Emacs you've already learned about radians, right? So just remember the conversion, like okay, 15 degrees, 75 degrees is not relevant. You can go and figure out the cosine tangent of 15 degrees and of 75 degrees on your own. I don't want to go through. Eventually we'll go through it, but that's a further topic, next chapter on further trigo identities. But here is still the basics. What do I want to talk about? Yes, conversion between theta degrees versus radians. Please try and remember the conversion rate. If you want to go from degrees to radians, you times pi over 180 degrees. To go the other way around, flip it around. It's a bit like converting from SGD to Malaysian ringgit times 3 over 1. But the other way around would be 1 over 3. Okay? Can? It's just a conversion rate, exchange rate. Can? Okay, good. Yeah, so of course, maybe in case you forget, I'll just write it down here. 30 degrees is actually pi over 6, pi being 180 degrees. This is pi over 4, and that is pi over 3. Can?
Okay.
Okay, good. Oh no, my line. Yeah, so let me just go through the worksheet now. What did you do so far? Let's see. So without using a calculator, you want to find the exact value of each of the following. Yeah, so yeah, I didn't explain that part the last lesson because it was getting quite late. And I sent you a video, so I hope you could understand. Oh yeah, you also need to know. Do you still recall sine rule and cosine rule?
Sine rule and cosine. Do I get the formula sheet?
I am not sure. Do you have I don't know. I just memorized it. Amex, right? You're talking about Amex contacts. You get MF26, but you get it. Let me think a bit. Let me go and see. AMF formula sheet. Okay, yes, you do get it. You get it. You will be given that the formula. But do you know how to use it? We will see later.
If maybe you like give me first.
Okay. C square equal to A square plus B square minus 2AB cosine theta. You won't need it for this first question, but eventually in the future we'll have some questions that you need to know. And of course, that's cosine rule. So it applies to the case where you have a triangle like this. Length C here, theta is opposite of the C. You got A and B at the side, surrounding the theta. All right. Then there's also, what's the other guy? Sine rule, right? Which is sine A over A equals cosine A. No, have to use a different angle. Cosine angle B over length A. Maybe I should use small letter. Equals to, of course, it can't be cosine. This is sine rule, right? Sine B. And then finally, sine of angle C over length C. Where the angles you are looking at is A, B, C length, but then the angle is capital C, capital B, and capital A. So basically, you need an opposite pair. Okay, like for example, you look at this pair, you look at this pair and this pair. Can? Okay, yeah, that's sine rule and cosine rule. For now, this is actually simpler. You can just use the exact values. Sine 60 is cosine 30. Very good. Oh, you know this identity? Okay, good. Cosine 30 is the same thing. So that means you just end up with root 3 over 2, root 3 over 2. Okay, or you could just go directly. Then you just have 2, half plus half is just 1, 1 times root 3. Okay, correct. Yes, next one, sine 30 minus tangent 45. So sine 30 is half, yes. Sine 45 is 1 over root 2. Cosine 45 also 1 over root 2. So that's just 1. So half minus 1. You get negative half. Okay. Next one is sine pi over 4 times cosine pi over 6. So pi over 4 is 45 degrees. Pi over 6 is 30 degrees. So sine of 45 is 1 over root 2. Cosine pi over 6. Cosine 30 is sine 60, which is 1/2. Then this becomes 1 times 1, which is 1. Then 2 root 2. This is wrong. Let me think. This is root 2 over 4, right? Is it not? 1 times 1 is 1. 2 root 2. Then you want to rationalize. So you multiply top and bottom by square root 2 over square root 2. So you end up with 1 times square root 2 on top. Square root 2 times square root 2 is 2. Multiplied by another 2 is a 4. Right? You can also key into the calculator directly. This fella here. Make sure you're in radian mode. Make sure you're in radian mode. Do you have your calculator with you? You can try sine of pi over 4 times cosine of pi over 6. Then you compare with square root 2 over 4. Oh, did I get it wrong? Let me think. Did I do something wrongly? Oh, right. There's a mistake. Oh. Sorry. No. Cosine of pi by 6 is cosine of 30 degrees, right? Do you agree with this part? Then cosine of 30 degrees, how come it magically turned into sine 30 degrees?
it should be sine 60.
Yes, correct. It should be sine 60. So if you, I mean, you actually don't need to convert it. I mean, it's just from the table of values, all sine 30, 45, 60, cosine 35, 30, 45, 60. You could just directly replace this. Cosine 30, I usually memorize the table here. I memorize this row 30, 45, 60, square root 1, square root 2, square root 3. Then after that, I use this identity to convert. So I know that this pair is the same, that pair is the same, that pair is the same. I bring everything back into sine first, and then I recall which of these three options is it. Tangent, I just memorize it. Memorize it. Okay, that's how I usually do it. So how I usually see it is pi by 4 is 45 degrees, so sine 45 degrees. Then that's really just 1 over square root 2 or square root 2 over 2. Then cosine of 30 degrees is sine of 60 degrees. Yeah, this should be 60. Then sine 60 is just root 3 over 2. Is that right? Yeah, then you should end up with square root 6 over 4. Is it right? Square root 6 over 4. Yeah. Square root 6 over 4. Yes. Okay. Yeah, so this is wrong. Can?
Okay.
Okay, moving on. Next one is tangent pi over 3 times cosine pi over 4 minus sine pi over 6. Okay, good. So pi over 3 is 60 degrees, so tangent 60 can. Cosine pi over 4 is tangent 45. Sine pi over 6 is sine 30. Good. Tangent 60 is 1. Is that right? 30, 45. That's not exactly right. Let's just copy down. Let's just look at the table. I'll copy and paste it over. I think it's not right, is it? Or are you doing something I'm not catching?
Root 3.
Tangent 60 degrees, is it 1?
Root 3.
Root 3, yes, okay. So it should actually be square root 3 or equal. This is fine. But for cosine 45, 1 over root 2 is fine. Sine 30 is half is also fine. So yeah, just make that edit. Then yeah, so it becomes square root 3 over square root 2 minus 1 half. But here we got root 2 and 2. How do you make denominator the same? Rationalize. Also multiply root 2 at the top and bottom. So you end up with root 6 divided by 2 minus 1 half, which is just root 6 minus 1 all over 2. Okay?
Okay.
Wrong. Okay, moving on. Next, let me see. Tangent 60 over sine 45 cosine 45. Okay, so tangent 60 is just 1. Error carried forward again. I mean, yeah, the same mistake. It's just supposed to be root 3. Then this is 1 over root 2, 1 over root 2, which gives you 1 half. 1 over half. Sorry, root 3 over half should be 2 root 3. Can? Good. Moving on. Next. Stop me if you got questions. Okay, so here, cosine, you want to try without using a calculator. I know it's very silly when you have a calculator. This entire thing can be keyed into a calculator and you can get the answer straight away. But the purpose of this question is to test you on your ASTC. Okay? And your understanding of reference angle, basic angle. You don't need a calculator for this. So sine 15 degrees is 0.3, cosine 45 is 0.7. So cosine 45 times negative sine 165, what would it be? Cosine 45 is actually just the value here, so substitute with 0.7. Sine of 165, so you have to draw the angle 165 degrees, and then you realize the basic angle is at the side here, based on the ribbon diagram. That is 15 degrees. Do you know what's the ribbon diagram?
Yeah.
So alpha, 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 those 4 positions. It's to remind you what is your alpha. So sine 165 alpha is 15 degrees, so you replace directly with sine 15. But this sine 165 itself, this is a what angle? Quadrant 2 angle. Quadrant 2 says sine is positive. So that means that sine 65 is really just sine 165 degrees. You just copy down the sine, but you replace the 165 with the alpha angle 15 degrees, and then you put a plus sign inside. Let me ask you a question. If it's cosine 165 degrees, what would it be equal to? Cosine of 15 degrees, but what's in front?
Negative.
Negative sign. How about tangent? 165?
Negative.
Negative tangent of 15 degrees. Is it clear?
Mm.
Can, but now there's an extra minus sign here that was originally there right from the beginning. So you just copy and paste the negative sign. Okay, here the sign 165. Oh, sorry, the negative sign here, just copy and paste it. The sign 165 got replaced with sign 15. So far, okay?
Mm.
Good. What is sign 15 degrees? Oh, right over here, 0.3. Sorry if my handwriting is not so neat. 0.3, so replace this guy with 0.3. So you end up with minus 0.3. But this is multiplication, so you end up multiplying positive with negative, you get negative 0.7 times 0.3 is not 2.1. Is it? Wait. Is it? I thought it's 0.21. Wait.
Hey, wait.
Yeah.
Yeah.
Negative
Ah.
0.21. Because you see, 7 over 10, then 3 over 10. 10 times 10 gives you 100, right? For negative.
Mm.
So 21 over 100. That's why 0.21. And I'm sure you know how to do that. Use a calculator if you need to. Now part B, 2 times sine 165 plus 4 times cosine 45. Okay, so sine 165 is sine 15. Don't need to change the sign. Good. Cosine 45 is just the value given, 0.7. Good. Sine 15 is 0.3, so sub in. Good. Let's just use a calculator now. 2 times 0.3, 0.6. Then you add on to 2.8, that's 3.4. Yep. Good. Next one, negative cosine of 135 minus 3 times sine 15. Okay, can. So what happens here? Cosine 135. Whenever the angle is not acute, not more than 0 degrees, less than 90 degrees, you need to use the Amax version of trigo definition. So cosine 135 degrees, you need to find its basic angle here, which is 45 degrees. Yes, correct. 45 degrees. So you can replace cosine 135 here with cosine 45 degrees. But wait, what's the sign? Here, quadrant 2 angle. This is quadrant 2 angle 135 degrees, which means that only sine is positive. Everything else must put a minus. So that's why you replace the cosine 135 here with negative cosine 45. This is very good. But the negative right from the beginning, just copy and paste. Very, very good. Next one, negative 3 stays there. Sine 15 degrees is just 0.3. Then here, minus becomes a plus. Cosine 45 degrees is 0.7. Is it actually, what did they give? 0.7 here. Okay, good. So let me change to green. 0.7. Then 3 times 0.3 is 0.9 with a minus. Subtract and you get negative 0.2. Very good. Okay. Can. That was only for obtuse angles. Of course, in quadrant 3, you can imagine that our question will get more complicated. But it's just the same thing. Draw the line and find out the angle, find its acute angle. It's always the same pattern. Let me write it down. Sine of a theta equals to sine of the alpha, and then it's either plus or minus. Depends on Q question mark of theta. Okay, Q1, Q2, Q3, Q4. Quadrant 1, 2, 3, 4. Okay. Is that okay? We'll see more examples later. Of course, that's for sine, but cosine will change accordingly. So I'll just put a slash cosine slash tangent as well. All right, I haven't talked about secant and cosecant. I'll just talk about it now. Okay, so this one is overlapping with the next lesson already, but let me just introduce more notation. I don't know why people came up with this, but sine, cosine, and tangent, they felt not enough. We need more definitions. So they came up with something else. They came up with this thing called the secant of theta and the cotangent of theta. Okay, let me spell it out. Cosecant, secant, and the cotangent. Okay, nobody ever spells it out in full in math. You just write it down like this. Some people even go to CSC theta, even lazier. Oh, they mean the same thing. I usually spell the cosec. Now, what's the definition of these three? the reason why I pointed it from sine, from cosine and tangent is because they're related. So cosecant theta is actually just 1 over sine theta. Oh, I should write it down like at the side like this. Cosecant theta is 1 over sine theta. Secant theta is equals to 1 over cosine theta. Cotangent theta is equals to 1 over tangent theta. How I remember it is here have co, here don't have co. Here don't have co, here have co. Here have co, here no co. Co, no co, co, no co. Co, no co, no co, 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 no co.
Yes.
By definition, sorry, need to memorize. This is not provided in formula list. It's just a name. You need to know this. Okay. Whenever, so let's say, just do a quick example. Let's say we got this is angle theta, 3, 4, 5. Tell me what's the cosecant theta, secant theta, and tangent theta. So, okay, maybe I should just demonstrate first. This is the first time I'm seeing it. Cosecant theta is 1 over of sine theta. I see co, I think no co, so sine, but 1 over. What is sine of theta? So opposite over hypotenuse, so 4 over 5. But you need to flip it around, so it becomes 5 over 4. Is that okay?
Mm.
Can Then how about secant? Secant, or maybe I should write down sine, cosine, and tangent first in case you're confused. This one, so that it's easier. Sine is this guy, cosine is that guy, tangent is that guy. Okay? Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay? Now, how about secant? Secant is 1 over cosine, so it's 1 over of 3 over 5, which is just 5 over 3. Tangent, tangent theta is, sorry, I mean cotangent theta. That's more interesting, right? Cotan, or just COT. Must be?
Of 3 over 4.
Very good, huh? Yeah, so so you just need to memorize, which is, I think cotangent is quite easy to remember. You just need to know that it's the flip version of tangent. But the one that will give you trouble is cosecant and secant. You need to go and memorize. Oh, co, no co, co, no co. All right, can okay. That's just a preview of what's to come. Actually not preview, it's part of the lesson. In next few weeks. Okay, question 3 now. In the diagram, you have triangle ABC. They are labeled with the following lengths. M is a point on BC produced. So BC, you extend in the same direction, such that CM is 5 cm, AM is 12 cm. You need to show the angle AMC is 90 degrees. Yeah, so basically just show Pythagoras theorem. Okay, very good. Yes. AC squared is 169, AM squared plus MC squared also 169. So therefore it's 90 degrees by Pythagoras theorem. Part B, express your answer as a fraction, tangent of angle ABM. So basically this angle here, you want to find the tangent. Tangent means what? And we also figure out this is 90 degrees. Tangent means what? Opposite over adjacent, right? So it's just 12 over 5 plus 11, 12 over 16. Did you get that? Very good. Then simplify 3/4. Okay, now cosine, cosine angle ACB. So this is when you need to know your ASTC. This is an obtuse angle. So that means cosine of obtuse is the same as sine, cosine of the, maybe I'll just write it down. The obtuse angle is just the cosine of the alpha, but then you need to care about the minus sign. Because this is a Q2, quadrant 2 obtuse angle. Quadrant 2 means what? Means you're over here. You are more than 90 degrees, right? If you turn here to here, it's 90, but you turn a bit more, so it becomes more than 90. But this is 180. The angle here is more than 90, but less than 180. Quadrant 2 angle. Of course, it could also be, you could add multiples of 360 to it. Minus 360, minus 360, minus 360. And it's still a quadrant 2 angle. We'll deal with it later. So here, angle ACB is quadrant 2. we convert it into its alpha, the reference angle. What's the reference angle here? You don't need to calculate it. You just need to know that it is that fellow here, right?
Mm.
Can you see? Angle ACM. So we just write down angle ACM. You do not need to calculate angle ACB and angle ACM, even though you can. I don't know what angle it is, but it doesn't matter. Cosine of angle ACM is what?
Adjacent 5/13.
Very good. So you can replace that fraction, the cosine with 5/13 fraction, but don't forget the minus. Answer. Is that okay? Can negative 5/13? Did you get the answer? Wrong. Oh no. You change the angle and you say it's sine. No. This only applies when the angles add up to 180. Right? Or are you saying that in general, cosine of 180 degrees minus theta is equal to sine of theta? There is a formula for involving this, involving the 180 minus 1. But I don't want to talk about it now. Nah.
Okay.
Not relevant. Don't need. Moving on. So yeah, negative 5/13 instead. This one, question 4, you need to use sine rule. Let's take a look. So you have this 75 degrees, this theta, and some other angle. Then you got two of their exact lengths, AB and BC, in terms of surds. The diagram shows a triangle ABC in which AB equals to blah, BC equal to blah, angle BAC is 75 degrees, and angle BCA is theta. Given that sine of 75 degrees is this exact value, have you tried using a calculator to check this?
No.
Try now. Radian mode, change to degree mode. Can you give me the decimal value of sine 75 degrees?
What do you mean by radian mode change degree mode?
Oh, if you were previously in radian mode, please change to degree mode.
Oh, okay. I wasn't.
Oh, okay, good. 0.9659. Then have you tried keying in this surds? Do you get the same answer? Convince yourself that you'll get the same answer.
Yeah, I get the same answer.
Okay, good. So we don't care about how it came about. Where did this formula come from? You can go Google online. How do you get this? Let me know. Send me a message if you want to. If you really want to know how this was derived. I'll send you a video link. Just use it for now.
No.
Then fine, without using a calculator, the value of sine theta in the form of, sorry, this is given. Value of sine theta in the form of a plus b root 2, where a and b are integers. So what do you notice straight away? Length, angle, length, angle. Let me make it more obvious. Green, purple.
Sine theta over 4, 3 minus 1 equal to sine 75 degree over. Then bring the length over. Bring this one.
Yes, correct. Let me just do it.
Then sine inverse that thing.
Yes, very fast. Very good. Okay, so let me just make it look neater a bit. This guy go here, that guy goes there, and then equal sign. Let's try to make it align since I can do it. Why not? Okay, equal sign align looks nice. Then what do we want? We want sine theta, right? So we should bring this down as well. Is that what you were doing?
Yeah.
Good. So honestly, this is not so much of trigo, it's more of a surds question. What's sine 75 degrees? This guy here. So we just replace it with root 2 over 4 times root 3 plus 1. Yeah, just replace it here. Then everything else copy and paste. Like this, Is that okay? Can good. So now we can continue. What did they want? Did they ask to find theta? Or did they ask to find sine theta?
Oh,
ask for
they
sine
ask by
theta.
sine
So do
theta.
you need sine inverse?
No, no.
Don't need. So this question doesn't require a calculator. If you try sine inverse, you cannot do it by hand anymore. You need a calculator. Yeah, so what do you do? Yes. Oh my goodness. This is
Wait,
gonna
why?
be a long-winded ride. Yes, correct. But maybe before you continue multiplying, we try to simplify numerator as much as we can. Anything to cancel? Yes, exactly. 4 cancels away. And how about this part? Root 3 minus 1, root 3 plus 1. Any identities?
Yeah.
Yes, correct. So we end up with root 3 square. Okay, I'll do it other side. Root 3 square minus 1 square, which is 3 minus 1, which is 2. Also, we are just left with a 2 multiplied by root 2. I'll try to simplify before you try to rationalize. If not, you're gonna have a very bad time. Anything else we can simplify? Very lazy. I want to simplify as much as I can. Not much. No choice. Okay, never mind. We have to do it. 3 root 2 minus 4 now. 3 root 2 minus 4. Have to do it. Okay, let's do that and distribute. So this guy, bracket, maybe I'll put a pair of brackets to remind myself I need to distribute. So 2 root 2 times 3 root 2. 2 times 3 is 6. Root 2 times root 2 is 2. 6 times 2 is 12. Right? Then 2 root 2 times 4 minus 8 root 2. All divided by a plus b times a minus b. A square minus b square. Is that okay? Your certs still remember or not? Hopefully. Yes. Must remember. This one becomes 3 square root 2 square, which is 9 times 2, which is just 18. Then you can you can use a calculator now for this entire thing. 4 square 16, 18 minus 16 is 2. Simplify, you get 6 minus 4 root 2. Okay, that's your format. A equals to 6, B equals negative 4.
Wow.
Can? No. Remember your certs. This one trigo plus certs combined together.
Cannot. Cannot. I'm not even sure I can remember what you told me. Oh no.
That's why you have to do the practice. You can gain muscle memory. Just remember, I think the easiest way is just equilateral triangle 2, 2, 2, perpendicular bisector. Then from there you work it out. Or isosceles triangle 1, 1 square root 2. Still remember 1, 1 square root 2, 1, 2 square root 3, 1, 1 square root 2, 1, 2 square root 3. Must go and memorize. I mean, that's why I did when I was many years ago. Okay. Yeah. Anyways, moving on. Another question. This one just certs. Just a recap. Express this in the form of a plus b root 5. It's used in part 2. Let me see if you did that correctly. I'll just check your final answer. Check if they are the same value. If it's the same, then yeah, confirm correct. So let's double check. 41 root 5 multiplied, then divide by 3 root 5 plus 2 is 10.527. 10.527. Something. Okay, then the other guy is 15 minus 2 root 5. 10.527. Okay, correct. Very good. Then next one, part 2. The diagram below shows a cuboid with a square base. So the height AB of the cuboid is root 5 plus 4. Given the length of the diagonal AC is this fellow, find an expression for BC squared in the form of C plus D root 5. So you need to see straight away that there is this hidden right angle. Can you see? I know it doesn't really look like a right angle. It looks like a acute angle if you're treating it as a paper. But this is actually 3D, okay? So there's a right angle here. So maybe if it's confusing, just redraw the right angled triangle. So let's try to make it straight. 90 degrees here. A, B, C. AB is what? Root 5 plus 4. AC is what? That fellow that I'm not gonna write it down. And then you have BC as an unknown. You want to find BC square, right? So what theorem do you use?
Pythagoras.
Pythagoras theorem. So AC square, then minus away root 5 plus 4 square. Did you do that? Okay, very good. Yes. Wow. Okay, let's see. So you see the reason why they gave you the part 1 is so that you can use 15 minus 2 root 5 instead when you take the square.
Oh my god. Okay. Okay.
Okay, yeah, so you're working.
By the way, I wasn't even able to do it.
Oh, okay. Should I check? Find the area of the square in the exact form. Let's see. Oh, by the way, this is part B. Oh, you need an expression for BC square. Okay, let me see. Okay, I'll just check your working. It's fine. But your method is correct. I mean, if it works, it works. Okay, this guy square, then 2 times this, 2 times this times this. 2 times 4 is 8 root 5. Okay, can. Then this guy square, you get 41 square times 5, which is 8405. Can. Then this guy, a plus b bracket square. So a square plus b square. This guy is 3 root 5 bracket square is 45. Plus 2 square is 4. 2 times 3 times 2 is 12 root 5. Okay, good. Correct so far. Simplify. 5 plus 16, 21. 8 root 5 remains. This guy can simplify. 45 plus 4 is 49. This is okay. Then you rationalize. Oh my goodness. A plus B rationalize. A minus B, A minus B. Correct. Then this guy, mistake here. Minus must bring in the bracket. So this should be a minus.
Oh, okay.
So other than that is fine. But now continue multiplying. This guy must distribute. Must remember there's an invisible pair of brackets top and bottom. So 8405 times 12. 100,860 root 5. Okay, and 840 times negative 49. Negative 41,100. Negative 411,845. Yes. Then this guy A plus B, A minus B. Just use a calculator to do this. If you want, you can also type in 12 root 5 bracket square minus away 49 square. And you end up with negative 1681. I think you key in wrongly. And then you realize that this guy and that guy can simplify. So let's just type that. Let's just write it down first. 100,860 over negative 1681 times root 5. Then minus minus become a plus. 411,845 over 1681. I already cancel away the negative. So that's why I didn't put a negative here. Is it clear? I'm going a bit fast. Can now? Minus 8 root 5 minus, of course, again, the minus sign. Minus 8 root 5 minus away 21. So let's just see if we can simplify that fraction. Horrible looking fraction. Negative 1681, and I get a negative 60. What a coincidence that it simplifies. Then the other guy, oh my, 411,845, 1681, you get 245. And then copy and paste the rest. So yeah, copy and paste. I'm just gonna change everything to black color. Black. Good. Carry on. So can we simplify further? Yes, minus 68 root 5. 245 minus 21. You end up with 224. Is that okay? Very good. So now this is your BC square. Are we done? No. Part B asks you to find the area of the square base. So you need to understand that this guy here, even though it looks like a parallelogram, it's not a parallelogram. Don't take it literally. It's a 3D diagram, so it's actually a square. If you look at it from a bird's eye view from top down, it actually looks like a square. So let's just redraw that square. There is BC. What is your length BC? I don't know. I only know BC square, and that's all I need. BC square, we have already expressed it as C plus D root 5. In this case, C is equals to negative 68. D is equals to 224. Right? So what? So I'm confused. This is what BC square. Okay, BC square, let me transfer that information to the top since I drew my diagram at the top. Okay, so what we have is BC squared. What else do we know about a square? All 4 lengths are?
Same.
So that means that we can have a length, let's call it X. Let's call it X here and here. What angle is this? Right angle. What kind of triangle is this? Right angle triangle. What theorem can we use?
Pythagoras.
So from there, we can find out the area of the square base by finding the value of x. But wait a minute. Let's think about it. Actually, I think I gave you something similar before at this question. But it was more direct. It wasn't so many parts. So let's just try to set up the equation first. BC square hypotenuse square C square equals to A square plus B square. Agree so far? Which is 2x square. But remember the goal, we are trying to find area of the square, which is actually what? Length times breadth, which is?
X square.
X square. So we just need to make x square the subject and we are done. So here you already have x square. Do you need to take square root? Don't need. Just divide by 2. If you try to solve for x, you're going to have a very bad time. You need to take a square root involving square roots. Square root involving square root. Remember the procedure? How to find? Need to square both sides first. A plus B bracket square a few times. And then after that, you compare coefficient and then you start to equate. Don't do that. Please learn to read the question, identify the goal. It's x square. Don't bother with square root thing. Yeah, just try to avoid square root as much as you can. It's very long-winded. You did the practice before. I'm not gonna torture you again. Okay, so BC square divide by 2. What's BC square? It's right over there. Copy and paste it. Then you divide by 2. So it's negative 34 root 5. Add on 112. Is that okay? Yeah, done. That's all. B part 2. Interesting question. Okay. You could use trigo, like half AB sine theta or something like that, but a bit overkill. Don't need so much. Just such is fine. Okay, that was the lesson question paper. Did you do anything else?
No.
Okay, Ken. Let's just continue then. What other files did I send you? Max. Trigo ASTC. Lesson 1.2. This lesson 1.2 is very important. Can you go and open the file? Yeah, let me go download the file. Hold on a second. Yeah, so this is the real question that will come out during A level, not A level, A max. Yeah, 1.2. Okay, I'll just go through this whole thing. Okay, go here, copy the question. Question 1 is already a little bit challenging. Let's just go. Do you prefer line paper or blank space?
How do you do line paper?
Oh, there's 3 dot then template.
Oh, I mean, it doesn't really matter.
I think I'll just use line paper in case my handwriting is bad. Okay, so let's take a look at this question 1. The diagram shows a triangle ABC in which angle CAB is pi over 3 radians, 60 degrees. Angle ABC is right angle. M is the midpoint of AB. Length of AC is 4 root 3. Without using a calculator, find the value of the integer m such that angle ACM is sine inverse of square root m over 75. So straight away, I see sine inverse and I think, sine inverse? How? I cannot calculate sine inverse on a calculator. I mean, without a calculator, without using a calculator. So that means that this is actually equivalent to asking us to find out that, prove that sine of angle ACM is equals to square root of m divided by 78. Okay? Let me copy the triangle first, so I don't need to waste time redrawing. Okay, good. So now this triangle, we know that m is a midpoint. So what's the ratio here? 1:1, right? Is that useful? It might not be so useful. Maybe we'll use it. I'm not sure. Let's think about it. What do we want? Square root m over 78. Where's my m? Isn't this meters? 4 root 3 meters? No, sorry. It's a bad notation. This is not meters. This is a variable. I mean, it's an unknown. It's not a variable. It's a constant. Unknown constant. It's not meters, okay?
Mm.
I hope you're not confused. It's not meters. The first time I read it, I was very confused. I was, huh? Why got meters here? No, it's not meters. Okay. Yeah, so we need to involve that length. Where does this length belong to? I see two triangles here. Okay, actually three. Yeah. 1, 2, as well as the large one, 3. Which two triangles involves AC? I noticed that this triangle involves AC. This purple one involves AC. What else? The green one also involves AC. Agree or not?
Mm.
Yes, good. So can we use the green one? Can we use the green one? What kind of triangle is the green triangle?
Right angle.
So what theorem can we use?
Pythagoras.
But Pythagoras theorem requires what?
Requires two sides.
You need the lengths, basically. You got 4 root 3m, that's good, but AB and BC, do we know the length or not?
No.
So that's the problem, lor. So that means that we have to get creative. You notice they gave you angle. You notice the topic is trigo. You notice right angled triangle. Then you must start to turn already. Or not Pythagoras theorem, then must be Tuakaso, right? So let's just try everything. Sine pi over 3, what would it be? Sine 60 degrees. It will be BC over 4 root 3 times m. Correct or not? Opposite over hypotenuse. But sine pi by 3, you know the exact value. This is sine 60 degrees, which is? Okay, use the calculator trick. Square it and square then square root. Pi by 3 is 60 degrees.
Which is root 3 over 2.
Very good, root 3 over 2. So that means that we now have BC, M, a number. Then that means we are almost there, is it? Well, actually, let's just look back at the goal. What we want, sine of angle ACM equals to some fraction. Where's my angle ACM? Over here. So what can we use that involves sine of an angle? It's so weird. This one not right angled triangle. This belongs to some weird triangle. Is there a certain rule we can use that involves the sine of an angle?
Sine rule.
Sine rule, exactly. So what do you look out for in sine rule? Opposite pair. One a length and an opposite angle. A length and an opposite angle. Right? Oh, sorry, I highlighted the wrong thing. Length and angle, angle and length. Right? So that means we need to involve angle ACM and its opposite length, which is AM. Can we find out the length of AM? A bit difficult, right? Maybe not the exact value, but maybe in terms of M, would that be possible? Yes. Can we find out, if we know AB, do you agree that we can find AM?
Yeah.
So we just need to divide by 2, right? From AB. So can we find out the length of AB?
Cosine pi over 3.
Good. Cosine pi over 3 will give you your AB divided by the hypotenuse 4 root 3m. So that means that, wait, cosine pi over 3, what is it?
Root 3 over 2.
Huh?
Wait, is it not? Wait.
No.
Oh, okay. It's half.
It's half, yes. Okay, so yeah, I'll leave you to work it out on your own. So that means that AB here is actually 4 root 3m divided by 2, which is 2 root 3m. Yes. Then that means that we know AM as well. Just half it.
Root
3m. Divide by 2 because capital M is midpoint. That's good. We have found our AM. So let's just summarize what's our result. We need this angle here, the sine of that angle, that's ACM. Angle ACM. We need the sine of this angle, which means we need to use sine rule. So we need an opposite length. We have successfully found our length, the opposite length AM. It is square root 3m. What else do we need? We know that there is length here, 4 root 3m. Let's just list down whatever we know first.
Oh,
Okay? Or does it mean we can just find the opposite angle here? Then we are done?
oh, sine 180 minus 60 minus. Oh wait, no, that doesn't work.
Not enough information. Right? Not enough information.
Yeah,
So we got a problem.
cm. But how do you get cm?
So how do you get cm? In terms of m?
Cosine rule.
Ah.
No, I don't know.
Can I actually? Oh, I didn't think I'm doing that. Oh, that's so long-winded.
No, what's the actual way? How you
It's
get?
not actual. I mean, there's no actual. Okay. What's my way, lah? See, actually, can I didn't think of that. Yeah, correct. Cosine rule can work. Oh,
I actually just said that as a joke. But okay.
but it works,
No,
because we have the
no, but
actual angle here.
No, but what's the actual way?
My recommended way is you know how to you want cm. We are focusing so much on this triangle because we want to. Okay, we're focusing on cm and we realize it's part of this triangle, but it's actually also a part of.
Oh, yeah. Oh, okay, yeah.
How?
Oh, okay.
Tell me the.
So you know MB is root 3.
Correct. MB is root 3m. You mean?
Oh yeah, root 3
M. For M.
Yeah.
Yeah.
Wow, that's so stupid. But yeah, okay. Then BC you can find from this.
Correct. Yes. Then you got BM, you got BC, so
Pythagoras.
exactly. That's it. Okay. Then once you have this CM found, you can just sign rule. Okay. Can Get the plan? Okay, we proceed. So we try to find out. Our goal now is to find out what is CM. I'll draw a question mark here. Find out what is CM. So yeah, let's just. Sorry, what were you saying?
BC is 6.
Okay, very good. This guy here, BC equals to root 3 over 2 multiplied by the denominator. Root 3 times root 3 is 3, 3 times 4 is 12, 12 over 2 is 6, but don't forget the m. There's the m. It's not 6, it's 6m.
Oh yeah. Wow, that's damn okay.
Yeah, it's annoying, but yeah, we have to deal with it. So yeah, then we need to find cm also. In that case, cm, let's just square it first. It will be root 3m bracket square plus 6m bracket square. Pythagoras theorem. Is that okay?
Okay.
Pythagoras, this is applied to triangle MBC. I know it's a lot of triangles going on, so that's why I write down the triangle. You don't really need to. It's just to remind myself. Now I square this, I get 3m square. I square this, I get 36m square. Altogether, I get 39m square, which means that cm is square root 39m. Don't need to care about minus because we are dealing with lengths here. Won't have negative. Okay, so I hope you're not confused by my little m and small m. Okay, this is capital. Capital is referring to a point. Then the little m is referring to the variable, the unknown constant here. All right, good. So we have cm. Then what do we do next? Let's fill in the blank first. Last step is to use what?
Use what?
Use what? What are we trying to find? Sine of angle ACM.
Or use sine rule.
Yes. Okay, I highlight it like that. So that means we have sine of angle ACM divided by root 3 little m equals to sine of pi over 3 divided by root 39m. What's sine of pi over 3? Sine 60 degrees, root 3 over 2. Is that okay? Can I go and work it out on your own? Root 3 over 2. Then what do we want? Sine angle ACM on its own. So multiply this fellow over. Then we copy the fraction over like that. Can? Good. Root 3 times root 3 is just a 3. 3. Okay. Then divide by 2 can bring down. So that just means we times 2 here at the bottom. The 3 is actually 3m. 3 times m. Anything to cancel?
Can you wait? Can the M be cancelled?
Can. The only time you cannot cancel is when it's a single term or when it's 0. Here, m we can assume it's positive. So this is 3 times m. This is square root 39 times m times 2. So m is a common factor, right? Common factor. So we can cancel away the factor. Yes, we can. So we are left with 3 over 2 root 39. But remember the question involved 78, right? There's an m. Oh, did I do something wrongly? Something is wrong. How come there's still a square root m? Uh-oh. Wait. Let me review first. Sorry. Oh my goodness. Sine of 60 root 3 over 2 BC is times 4 root 3 and 6m is fine. The skyline cosine adjacent of hypotenuse AB over 4 root 3m. This is 60 degrees, cosine 60, sine 30 is half. Okay, good. Cross multiply, you get 4 root 3m over 2 root 3m. 2 root 3m is AB. AM is half of AB, so you divide by 2 is root 3m. Okay, so what? So BC is 6m. Why? Oh, it's over here. Okay. Did I label my diagram wrongly? No. Root 3m there. Okay. cm square. Why? Because I want to use sine rule. But why square here? Pythagoras theorem on triangle MBC. Focus on triangle MBC. 6m here, root 3m here. I don't know what that length is. So I can use cm square equal to root 3m bracket square, 6m bracket square. Square, you get 3m square. Square, you get 36m square. 36 plus 3 is 39 m square. Take the square root, you get square root 39 square root m square, which is just m. You got cm already. Fill in the blank here. Did I fill in anything wrongly? I hope not. Let's see. So you want purple over purple. So sine of angle ACM over root 3m. Then you want blue over blue. So sine of the angle pi over 3 over square root 39m. Sine of pi over 3. Pi over 3 is 60 degrees. So sine 60 is root 3 over 2. That's okay so far. If I multiply by root 3m, yeah, it definitely works out. Something is weird. Okay, let's just continue simplifying this. I think my working is fine so far. Yeah, so this 2 is actually the 2 root 39. Maybe we combine together. See what we get. We'll get square root 4 square root 39, which is square root of 120 plus 36, 156. That does not help. Okay, I think maybe the question had something wrong and I forgot to edit it because here the solution is fine already, right? I don't think there's a mistake. So therefore, angle ACM is actually what? Sine inverse of 3 over 2 root 39. Right? Did I do something wrongly? Oh, there's a square root m involved. That's a bit weird. Okay. I think I'm going to skip this question first. I will get back to you on this because it's different from the answer. Is that okay? Can?
Yeah.
Okay. Good. I will get back to you on this guy. All right, that's question 1. Moving on. Now it's a little bit easier. Okay, let's try this. Not so much on problem solving, but more of just recalling the rules. So this is question 2. You want to express each of the following in terms of the trigonometric ratios of its basic angle. So basically, it's an exercise on ASTC and basic angle. So what is cosine of negative 320 degrees corresponding alpha? So that's when you need to draw a picture. Like this. Oh, so where is negative 320? You start with positive x-axis, you rotate how much? 320 degrees, but clockwise or anti-clockwise? Minus sign tells you it's
clockwise.
Clockwise. So I hope you remember the angles here. 90, 180, 270, 360. Too much already. So where do you go? Maybe I write down 90, 180, 270, 360. So where should I stop? Exactly, over here. So this is what quadrant? Quadrant 1. Okay. 2, 3, 4. Can you remember? 1, 2, 3, 4. Top right, top left, and then ASTC, correct. Yes. But before that, can you label my alpha? Where's my alpha? Is it here or is it there? Option 1, option 2.
Isn't it option 2? Wait, what am I thinking?
Yes, correct. Option 2. Oh, ribbon diagram is to remind you that it's option 2. So if you draw a ribbon, like the angle is this guy, right? I mean, sorry, the line that we have drawn is this fella that I'm highlighting in pink color. Then the alpha in the diagram is always here or here or here or here. Pink color line means you refer to the nearest alpha, which is here. Not there, not at the top. Is it clear? Also not the angle at the top here. I know there's some of my students they are super confused and they tell me that I got this angle here, right? So there must be my alpha at the top. Wrong. Please don't. I never teach you this. It's not at the top. It's also not at the side. It's only at this position here when it's a quadrant 1 angle. If it's quadrant 2, it's over here. Quadrant 3, it's over here. Quadrant 4, it's over here. Can? Ribbon diagram. Can understand? Yeah, write down ribbon diagram. Ribbon diagram determine position of alpha. Where is the alpha? So it's position 2. Okay, not 1. Maybe I'll put a cross like this. I hope you don't confuse it with an X. Okay, so anyways, that's alpha. So what's alpha? In this case, alpha equals to? It must always be a positive number, by the positive angle, by the way. Positive and acute. So what is alpha? Maybe I should draw in the 330.
Alpha is 360 minus 320, 40.
Correct. Yes, it's just 40 degrees. So you can go work it out. Basically, angles at a point. 360 degrees, you already got 320, remaining must be 40. So that means that you can now convert this into cosine of 40 degrees. But what sign? Plus or minus?
It will be positive.
Positive. Yes, because here is A. A means all of the sine, cosine, tangent are positive. So that means it's plus. Since we know all the sine, cosine, tangent is positive, how about secant, cosecant, and cotangent? Can we work out the SIGN sign of them? Let's say it's quadrant 4. What does quadrant 4 say? Okay, am I confusing you? Are you confused?
Yes.
Okay, never mind. Forget secant, cosecant, and cotangent. Never mind. Don't confuse you. So what you need to remember is I should write this down in case you get confused. Sorry. A means all. S means S is referring to sine. C is referring to cosine. T is referring to tangent. When I say all, what I mean is sorry, let me copy this down first. 4 times. The first one and the fourth one. So when I say all, right, what I mean is positive for sine, cosine, tangent. When I say sine is positive, I mean sine will become positive, the others will be negative. When I say C here, it means cosine. It means cosine of an angle in quadrant 3 will be positive, the others will be negative. When I say T for tangent, it means that tangent will be positive for an angle in quadrant 4. This is quadrant 4. Then the others will be negative. This guy is quadrant 1, that guy is quadrant 2. Is that okay? Can good. ASTC, all science teachers crazy, add sugar to coffee. Anyways, this is plus sign. Why? Because we are in quadrant 1. Can you refer to this angle? Maybe I should circle this one because Q1 ASTC. Right? Can Okay, so yeah, just ribbon ASTC. Okay, that's it for this question for part A. Moving on to part B. Can you try tangent negative 64? What will it be? Draw a circle first. Okay, don't need circle lah. Yeah. Negative 64. Can you draw a line to represent angle negative 64? And what is what?
I know I can't draw. Just now can draw. Oh, now can.
Oh, okay.
Oh.
Huh? Wrong.
Wait, why?
Negative. Clockwise and declockwise.
Clockwise.
From the positive x-axis, you rotate clockwise by 64. Much better. Yes. Okay. Must be always starting from the positive x-axis. Then you rotate clockwise. This guy, negative 64. So what's my alpha?
64.
Just 64. Okay. Then this will be
Negative.
negative. What? Cosine.
Well, negative tangent.
Tangent of
64.
alpha, which is just 64. Don't have the minus. Which is the same as the identity I told you just now, right? Negative bring out in front. Okay. You could also use the this following rule, ASTC, to figure out those identities. Tangent negative theta equals to negative tangent theta.
And
No,
then
must have you need a minus sign. You see, you are writing it a bit wrongly. Must have minus sign that, yes.
Here.
Correct. Inside that must have pair of, how to write it? Tangent of open bracket negative theta. Like this guy, negative 64. The bracket must be around the angle. Equals to negative tangent theta. Likewise for sine. Not tangent, sine of negative theta. It's just negative of sine theta. Is that okay?
And then for cosine, yes.
Cosine negative theta is equal to?
Just cosine theta.
Yes. Should we do an experiment? Okay, actually, I don't think it's worth the time. No. We already talked about it. It's fine. Let's just move on to part C. Okay? Part C, sine of negative 2 pi over 3. Any questions? No? Okay. Maybe as I like to convert it into a degree first. How many degrees is this?
Negative 180.
Wrong.
What?
Pi is 180. Pi equals 180 degrees.
Oh, 120, negative 120.
120, negative 120. Yeah. So this is exactly the same as negative sine of negative 120 degrees. Then where is my line? What is my alpha?
Your alpha is 60.
Very good.
And then tangent positive, the rest negative. So this will be negative.
Negative, correct, yes. So negative of?
Negative sine 60
Very good, yes.
degree.
Good. Very good. Yeah, so and then T lah, huh? ASTC. Okay, good. Part D, let's do the same thing. Part D is tangent negative 7 pi over 4. Over 4. Maybe you convert to degree first. What, 7 pi over 4? Oh, you could think of it like this.
315.
You could think of it like this. Pi over 4 is really just 45 degrees, right? Which is half of our 90 degrees, right? This is 90, so that's 45, 45. So when we say negative 7 of these pi over 4, you can think of it as I am taking 45 degree turns 7 times clockwise. So it means 1, 2, 3, 4, 5, 6, 7 here.
Okay.
Does it make sense?
Okay.
Turn clockwise, but 45 degree each time, 7 times.
So 270 plus 45.
Yes, correct. Oh, yes. 270. Well, you have to be a bit careful because it's negative. So 270 plus 45, but with a negative. Yes, correct. You can do that too. Anyways, I just need you to show me this and then figure out what's my alpha. Alpha is and draw the direction. Yes.
Alpha is this, which would be 45. Alpha 45.
45 degrees. Very good. Yes. Hey, let me see.
So equal
Positive.
tangent 45
Plus or minus sign in front?
plus.
Plus sign. Yeah, because here is A. 41555 10. Yes, correct. Good, good, very good. So you understand the idea behind all the ASTC and the angle already, right? By now. Okay, let's just continue practicing because it's quite important. Application questions. Let's go. Let's try question 3 now. So question 3, what we have, we are given that sine 50 degrees is P. Express each of the following in terms of P. So what is 50 degrees here? It's really just the alpha lah. But basically you're supposed to work it out yourself. You realize that every single question the alpha is 50 degrees, or maybe the complement, which is 40 degrees. Okay, I will let you work it out. We'll work through it together. So let's see, sine of 230 degrees. Yep. Where is it? Good. Where's my alpha?
Your alpha will be
Draw the alpha.
50
Draw the alpha
degree.
on the this diagram. Can you draw the alpha? Where is it? Very good. Some students, they get confused. They'll think that it's like somewhere here, which is not correct. Shouldn't be there.
Yeah, but it's very, I don't know. There's no way better to remember than to draw this thing.
Yeah, draw the ribbon. Yes, exactly. Yes, exactly.
No, there's no other way.
You're asking if there's a better way.
Yeah.
No, not that I know of.
Oh, okay.
Let me know if you can think of something better. Because it's a definition. And this ribbon diagram is just a mnemonic. Some
Okay.
students, they choose to memorize it as if it is 230, which is more than 180, less than 270, I will take this value, I minus 180. Why?
Oh,
I
no,
don't
no,
draw picture, I just memorize minus 180.
no,
I see a
no,
number in
no,
between this and this, and I minus 180. I don't draw picture. I tell you
no,
that's a very, very bad idea. Don't do that. Okay,
okay.
visualizing is much better. It will help you in a topic in the future called complex numbers. If you practice it, if you practice this topic well. Okay, visualizing the angle. Because this is really just trigonometry and complex numbers are really just almost the same thing. You need to learn it very well. Anyways, so yes, your alpha, what was it again?
My alpha 50.
Very good. So theta is 230, alpha is 50.
It's
Very
in third quadrant, so negative.
Q3 is T. Yes, A S T C. So T is positive. Alpha was what again? 50 degrees. Then that means this is equals to sine 50 degrees, but tangent is positive there. Everything else minus. So minus sine 50. But wait, what's sine 50? It's P. So this is negative P. Part B now. Cosine 50 is so what's the alpha?
Alpha 50.
Alpha is 50, so you convert it into what? Cosine
Cosine
50 again. I can't do anything, right? So here you need to draw the right angled triangle. The trick here is to identify your 50 degrees and identify a right angled triangle here, 90 degrees here. So what we need, what did they tell you? Sine 50 is P, right? So what is sine?
Oh,
Opposite
then
of
you have 40 here. Then you have 40 here.
can also, but what I'm going for is to just focus on the 50 degrees, and sine is opposite over hypotenuse. P is really just P divided by 1. So I can label P here, 1 here. Sine 40, then how do you express in terms of P? A bit difficult, right? So you still need to draw the triangle. You still need to draw the triangle at the end of the day.
Oh,
And then here, if you want, you can label 1 minus P square, but is that relevant? I don't know. Let's see. So what is cosine 50 now? It's relevant. It's relevant. Do you get how I got this? Pythagoras. So what's cosine? Divide by 1. Yeah, so of course you don't need to divide by 1 if you're fast. Yeah. Very good. Let me write down the working. Yeah, copy. Yes. Okay, so you need to use Pythagoras theorem. Another way to do it without thinking about, is this quadrant 1, quadrant 2, quadrant 3? Very simple. You just need to, okay, we look at part C first. We look at part C. I'll explain it once I go into the example. Easier. This is tangent negative 130. You do the same procedure. Draw the diagram. Negative 130 is clockwise, anti-clockwise, clockwise. So over here. What's my alpha?
This one. 50.
So tangent 50 degrees, positive. Then what's the sign?
Positive.
AST, yeah, positive. Very good. Then how? Tangent 50.
Draw right angle.
Yeah, just recycle, huh? Don't need to care about drawing it in this particular quadrant. I strongly recommend you to just don't think about quadrant at this stage. Just draw a standard right angle triangle. I like to draw quadrant 1 triangles because I'm used to it. And that's what I was taught. And that's what my teacher used to do. So 50 degrees, just label over there in a quadrant 1 right angle triangle. Then just don't care about the sign, plus or minus, whatever, doesn't matter. Just get the absolute value length. In other words, we know sine 50 is P, so it's P over 1. Opposite over hypotenuse, P over 1 gives me P. That's how I get my sine 50 degrees is P. Then from there, we figure out, C square minus P square equals to A square. So it's square root to get the length A. Pythagoras theorem, which is square root 1 minus P square. And then tangent 50, opposite over adjacent in this triangle. So opposite P over adjacent square root 1 minus P square. Is that okay? Can? Good. Pythagoras theorem. So what you realize? Trigonometry, such geometry, coordinate geometry when you're drawing circles, and other topics. What is it? Such exponents. In particular, there is also Pythagoras theorem. Everything is combined together. Do you start to see that everything is combining together? You need to know everything in order to learn trigo. So it's getting more difficult, right? Later, it's going to get even more difficult when you learn differentiation, integration. You're learning new things that's building on top of this. Remember, I draw for you a pyramid of math knowledge. Like food pyramid, I don't know. There's all these knowledge you need to learn. Algebra, trigo, exponents, logarithms, slowly building up towards differentiation, integration at the top. Differentiation, integration. Okay? All these are what we call pre-calculus knowledge. Calculus is differentiation, integration, and limits, but it's not in the syllabus. We are still at the foundations. Okay? Just to give you a roadmap.
I can't believe in JC they just expect us to
learn all this.
Yeah.
That's why A-Max is a prereq.
But they expect us to just like with no go from E-math to H2 math. Then I'm like, okay.
Yeah, so that's what most schools they don't offer H2 to people who don't take A-Max. Yeah, that's why. A lot of content knowledge. Anyways, moving on. Part D, sine 40 degrees. Sine 40 degrees. How? Oh no. 40 degrees, I don't know how. Then you draw the right angle triangle, you realize 50 degrees here, 40 degrees there, which is what you were talking about just now. And sine 40, opposite over hypotenuse. Let me label the length first. So sine 40 is opposite over the hypotenuse. So it's just square root 1 minus p squared divided by 1, which is square root 1 minus p squared. Is that okay? Another way. Memorize the identity. Sine 40 degrees is the same as cosine 50 degrees. Good thing is it's fast. Bad thing is you need to memorize. 40 and 50 degrees add up to 90. Then cosine 50 is adjacent over hypotenuse. This one no choice. You end up still need to draw the triangle. So is there any value to memorizing this? Maybe not. Huh? Correct. You memorize this one. You memorize the identity. And then cosine 50 degrees, you still end up having to use the triangle. Straight away, why not just straight away draw the right angle triangle, identify that 90, 50, 180 minus 50 minus 180 minus 90 minus 50 gives you the 40 degrees, and then use the triangle straight away. But the tricky thing is you need to be able to identify there's a 40 degrees here. Okay? If you couldn't identify the 40 degrees, then too bad. Okay? Ken? Paddy, okay? Can Now this is when sine 50 degrees equal to P, and you'll realize that 50 degrees is the acute angle. But what if it isn't? What if it isn't? What if it gets more complicated? Which is what we have over here. Question 4. Okay. So let's see. 50 degrees was easy to work with, but now if it's 160 degrees obtuse angle, then how? Still can. Just need to use your quadrant and ASTC rules and Pythagoras theorem. So cosine 160 degrees equals negative Q. Express each of the following in terms of Q. So what I like to do, whenever I see angles that are big, I don't like big angles or big numbers, so I convert them into smaller numbers. Can you tell me cosine 160 is equal to what?
Wait, can you say that again?
When I see 160 degrees very big, I don't like. I want to make it smaller. So do the same thing in terms of basic angle. Straight away, this one don't need to remind you already. You should automatically do it even without instruction. Convert into basic angle. In terms of basic angle, what would it be?
Wait, what I mean? Like do this or
yeah, correct. But 160 is positive, so Alpha equals
Alpha equal 20, cosine 20. Negative cosine 20.
negative. Very good, because it's S. All science teachers crazy. S is for sine, then cosine must be negative. Okay, very good. So this is also equals to negative Q. From there, we deduce that cosine 20 degrees equals positive Q. Is that okay? Can or not? Can, good. So yeah, so what we have done is we have made the complicated 160 into the simple 20. Then it's easier to work with. Okay, cosine 20 equals to positive Q. Let's begin part A. Part A, you want cosine 20. Oh, there we go. We have our answer already. That's why it's part A, so that we can use it now in part B. Part B requires sine of 160 degrees. Then how?
Only just
just you recycle the same diagram. 160 degrees is here. What's my alpha?
20.
Alpha is 20 degrees.
Positive. So negative Q.
Let me think. Positive, and then yeah, correct. No, wrong. Cosine of 20 degrees is positive Q. Here we have sine. So what do you need to draw?
Right angle.
Right angle triangle. Don't care about quadrant 1, quadrant 2. Just draw a 20 degrees for me and a 90 degrees. And what's the other angle? Is it relevant? 70 degrees. Is it relevant? I don't know. Cosine 20, let's see. We know it's Q, right? So Q is just Q divided by 1. So where's my Q? Where's my 1?
Wait, sorry.
Yeah, very good. And then the other length here will be square root of.
Wait, I mean 1 minus Q square.
1 minus Q square. Yes, just be careful. Hypotenuse square minus the adjacent square. Great. If you want, you can. If you are confused by how to derive this, let's just call it x. So 1 square equals to Q square plus x square. Make x square the subject, you get 1 square minus Q square. Solve for x, you get square root of 1 minus Q square. 1 square is just 1. Okay. I hope you can work this out quickly. Because there's a lot more work to do. You need to be able to do it fast. Must get very familiar with this. Okay, so square root 1 minus Q square. So anyways, maybe I should just equal x on the right side. Square root 1 minus Q square. Then how to find sine 20 now? Fraction, opposite, so. Why is it? Sine 20. What's sine 20 now? Look at the triangle.
Square root 1 minus Q square. Yeah.
Over 1. Yes, exactly. Which is just square root 1 minus Q square. Don't need. The divide by 1 doesn't do anything. Okay, very good. Part B is done. Let's move on to part C. How about tangent of negative 20 degrees now? Same trick. Find your little fish, alpha. Alpha reference angle, acute angle. Or you could use the special identities you know. Do you recall the special identity?
The special identity.
Tangent of negative theta is?
Tangent of negative theta equals to negative tangent theta.
So in this case, theta is 20, right?
Negative tangent 20.
Very good. So negative tangent 20 degrees. That's good. Because tangent 20 degrees, we've seen 20 degrees before. Over in this triangle. So I'm just going to recycle. Okay, I'm just going to recycle it. Save some time. Then alpha is what? Doesn't matter anymore since we use the special trick. So one, memorize negative angle identity. Then recall. Then negative tangent 20 will be what? Negative. Look at the right angle triangle.
Opposite. Square root 1 minus Q square divided by Q.
Very good. That's it. Okay. But don't forget the minus sign. Alternatively, you could have done it using the alpha method, the find the alpha first. So tangent -20 will be what? Clockwise -20 degrees. Where's my alpha? Ribbon diagram. So draw a ribbon. Realize that here is alpha. So that means here is alpha. Alpha will be positive angle. So alpha equals to positive 20 degrees, which means that my tangent -20 is actually tangent of the positive alpha 20 degrees, the positive angle, positive acute angle, reference angle 20 degrees. But here is ASTC, C is positive, so tangent must be minus negative, which is the same as the thing we memorize. Okay, so maybe it's better if you don't memorize, just use the alpha trick because it always works. Can? ASTC ribbon diagram, then negative tangent 30. Yeah. Okay, good. That's part C done. Let's move on to part D, cosine 70. How to get cosine 70?
Mm,
70 is what kind of angle? Acute angle. So
yeah.
But very special 70. It looks very familiar. Where have I seen 70 before?
Wait, what do you mean?
Where have I seen 70 before?
Okay.
Car. Okay, yeah, that's it. Yes, adjacent square root 1 minus q square over 1. Of course, don't need to divide by 1. Okay, I'll just write it down to remind you. Adjacent over hypotenuse. Is this okay? Question 4? Okay, almost there. Yeah, almost done with this worksheet. Okay, let's see. I've got, actually not really. Question 5, let's go on. So now is the next type of question already where you start off by giving you the actual number instead of just P and Q. Then you need to figure out what is sine, what is tangent, what's all the other ratios without a calculator. How? Let's see. So here's the trick. You don't try to cosine inverse or anything and solve for theta. I haven't teach you how to do it when the ratio there is negative. So far in Emacs, you've only been dealing with practical situations. It's like a tower or a tree, and then you have another tree, then the distance between the tree. So distances or lengths are always positive. However, here we take cosine of an angle and we get a negative ratio. This is allowed in Emacs, but it doesn't make sense in a practical scenario because you have a negative. Right, ratio between lengths are opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. It should always be a positive. So here, when there's a negative, it's something totally different. I have yet to teach you how to solve for the theta when the right-hand side is negative. You are not allowed to just cosine inverse a negative 4 over 5. It will introduce some problems. Cannot. Not that easy. So the goal here is to figure out when to do it this style. Let me demonstrate. Cosine of an angle, they tell you 180 to 270. So where is 180 to 270? It's over here. How do I represent the angle? I'll just circle this region. Okay. Now must remember ASTC. ASTC. So here, what happens? Sine and tangent positive. So who's the odd one out that will always be negative here? In both
always
quadrants.
be negative.
All right.
How won't both be negative cos cosine? Wait, what do you mean?
Yes, correct. Cosine. Cosine will be negative in both of those quadrants. You agree? Here, S means only sine positive, so cosine is negative. Here, T is positive, so it means cosine is negative. In both scenarios, cosine is negative. That's the common pattern here, which is why here cosine theta will have a negative 4 over 5. Do you get why it's negative now?
Okay, so it's for sure in quadrant 2 or 3.
Correct. Actually, you didn't even need this information. You could have deduced that it could be in quadrant 2 or 3. 2 or 3 without this information. If they didn't tell you this, you can also make the same conclusion. Make sense?
Mm-hmm.
Can okay, good. So now we are going to try and calculate sine theta and tangent theta. So how do we do it? Here's how you do it. Ignore the negative. Here's how I do it. ignore the negative sign. Then you just conclude that there's some cosine alpha that will be positive 4/5. Since cosine alpha is 4/5, what does it mean about my sine? A bit difficult to work it out, right? So we draw a triangle. Ignore, then conclude. You basically, maybe just explain this step first. Replace the theta with alpha. Okay, that's your step 1. Step 2, step 2 is to draw right angle triangle involving alpha. So I like my quadrant 1 angle. Even though I know alpha is somewhere here and there, quadrant 2 or quadrant 3, I'm just going to draw the right quadrant 1 angle because it's the simplest way to do it and you will get the right answer. Alpha is over here. I know that it's 4/5, so it's adjacent here over hypotenuse there. Agree so far? 90 degrees? Then what's my other remaining length here? You can work it out. 5 square minus 4 square, take the square root, you end up with a 3/5. Can? Good. So what is sine alpha in this case?
Sine alpha is 3/5.
3/5, very good. So that case, in that case, since they're asking for sine theta and tangent theta, why did I find this? Is because question asked for sine theta. Likewise, since they asked for tangent theta and tangent theta, so I will also find my tangent alpha. Can you tell me what's tangent alpha?
3/4.
Okay, very good. So now step 3, step 3 is to answer the question. Answer the question. You have sine theta. You know that theta is what angle? It is in between. Okay, cannot remove this. 180 to 270. So it's quadrant 2 or quadrant 3. Right? Yes.
Yeah.
Okay, then in that case, what will be your sine?
I mean, if it's in the, it will be positive, I guess.
Actually, let me think a bit. Would it be positive or negative? Could be either, right?
Yeah.
That's a bit odd. Okay, this question is a bit funny. They didn't give enough information for you to immediately conclude whether it should be positive or negative. So the theta could be in either quadrants. But the theta is a fixed value.
Hey, wait, isn't it just the third quadrant?
Why?
Because 180, then it's 270. No.
Oh, right. Sorry. Oh my goodness.
Then this will be negative 3/5. Then
correct.
the other one will be positive.
Very good. Yes, you're correct. Sorry. I didn't read carefully. 180 is this quadrant 3. Oh, no. Yes. Yes, correct. So sine theta is just sine alpha, but with extra negative. Tangent theta is just tangent alpha, but don't need negative, it's just positive. So that will be negative 3/5, positive 3/4. Yes, good. Okay, 3-step procedure, Ken? Okay, good. Now let's move on to questions. Did I finish the question already? Question 5. Yes. Move on to question 6. Okay, same idea, but just a little bit more complicated because they changed the angle. Okay, let's take a look at question 6. So you're given that 270 degrees, A is between 270 and 360. Okay, this one I must think carefully. 270 to 360 is here. Okay, quadrant 4. So it's A, S, T, C. Okay, good. Can not nothing wrong, this time. Okay. Then you have sine of this A is negative. Makes sense, because here only cosine is positive. So what's the procedure? Let me take a screenshot of the previous question and put it at the corner so that you can have a reference. take a screenshot, shrink this down, put it at a corner like this, and then I zoom in. Okay. So what do you do?
Assume positive.
Not just that. Replace, ignore the negative and replace
Oh. Okay.
the A with a
Um.
alpha. So sign alpha equals to positive 5/13. Very good. Step 1 done. Step 2, draw. Okay, it's 12.
What is rule 144?
12.
12. Okay.
Yes, 5, 12, 13. If you want, you can memorize these triangles. 3,
Oh,
4,
yeah.
5, 12, 13, 7, 24, 25, 8, 15, 17. And there's a bunch more. They are called primitive. You can go and Google this. Primitive Pythagorean triples. Okay. How to generate these numbers? It's not guess and check. That's okay, a bit of guess and check, but there's a more refined way to do it. You can go and Google and let me know what you find if you are interested. Okay, then how about question 2? Step 2, step 2. Oh, sorry, I should show the working.
Wait, what?
Oh, blocked.
Wait, what they want?
What do they want? Find the value of cosine A and of
Oh,
tangent
okay.
A.
Okay, cosine.
Can you just remove your drawing out the right part?
Oh, yeah, sure.
Okay, can. Good.
Cosine A, adjacent 12/13 and positive. Then tangent A equal negative 5/12.
Opposite of this. Tangent in this case should be negative. Sine in this case should also be negative. But they want cosine. Cosine is positive. Okay, yes, correct. Yes, correct. So cosine A is equals to positive cosine alpha, which happens to be the adjacent over hypotenuse 12/13 positive. Then the tangent of A is just tangent alpha, but what sign? In this case, we are at quadrant 4, so C is positive, tangent is negative. So negative of tangent alpha, which is opposite over adjacent, 5/12. Okay, good. 10. Easy. Very good. Moving on. Question 7. Let's see. Question 7. This time is a new type of question. I'll just go through entirely first. If I can just start a new page. This is question 7. Let's read. Tangent A equals negative 5/12. Cosine B equals negative 1/√3. A and B are in the same quadrant. Find the value of each of the following without using a calculator. So this one a bit sophisticated. Let's think carefully. Tangent A here is negative 5/12. I don't care that it's 5/12. I care that it's less than 0. Cosine B here is negative 1/√3. I also don't care its value. I just care that it's negative. Can you tell me if they are both in the same quadrant, or before that, tangent A is negative, what quadrant could it be?
Means is in the second quadrant. Mean they're in the second quadrant.
Correct. Yes. Tangent negative, cosine negative means that only it must be in second quadrant. S or B. If you do it step by step, tangent A less than 0 would be what possibilities? The only place where tangent is negative is S or C. Okay, then if I just change color, I say green, use green. This time if you look individually at cosine B being negative, you realize that there's only 2 other possibilities, which is these 2 quadrants. Right? Then if you take the overlap between them, take the overlap like this. Okay, what happens? You realize that the only overlapping region is over here, which is quadrant 2. Okay, so that must mean, and that's because they told you A and B are in the same quadrant. So your conclusion is A, B, both in quadrant 2, the S. Okay? Can carry on. Now find sine A. This one you can do. Sine A. So which ratio would you focus on? 10A or cosine B? Of course, it will be 10A, the one involving A. Right? And just nice, the question also give A, and B, B. Okay, so what should you do? First step. Rewrite the 10A as tangent.
Near the 10 AS.
Tangent alpha. Okay. Acute angle, the reference angle, basic angle, equals to the positive 5/12. Okay. Then step 2, maybe also step 3. Step 2 is to draw the right angle triangle. So good, 5, 12, 13. Then step 3 is to conclude. So sine A is
Sine A is
sine
5
alpha.
over 13.
But what is the sign? SIGN? Because
Is
we're in quadrant 2, only sign is
positive.
positive, so positive. Then sine alpha is what? Opposite over hypotenuse 5/13. Is that your answer? Yes, good. Part B, cosine A. So here, since we already did the work for the first two,
Negative 12 over 13.
yep. Correct. Then now, okay, change to angle B. Same thing now, but you have to redo now for cosine B. So maybe if I can just squeeze them all on one page. Part C is now dealing with angle B. So what do we write? Cosine. Instead of angle B, we write cosine alpha. Okay, I know the alpha is the same. So I'm still gonna use alpha, but the alpha is different. This line is to separate them. The alpha in part A is one alpha. The alpha in part C is a different alpha. Do you want me to use a different notation?
What other notation is there?
Beta. Some other letter. Beta. Yeah. Alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu. Mine is sigma. Gamma. Yeah. Okay, and gamma not very nice. It's like the terminology for the COVID virus. Like this, gamma. Okay, you can just go and Google those. Okay, you know what? Just to be more precise, I'll just use a different letter. Let's say use beta. I don't usually use beta. I just use alpha all the way. So cosine beta in this case equals to the positive version, so 1 over square root 3. Is that okay? Good. So what do you do next? Step 1, rewrite as the acute angle and then change to positive. Step 2, draw. Right angle triangle. Okay, wait. Sorry. Okay, yes. Disrupted your drawing. So that will be so what's the last length?
Oh my god, what the? But didn't you say not to do this?
Oh yeah. Sometimes it's irrelevant. But I think it's quite simple. Just do it. It's quite simple. Just calculate it. What would it be? What do you get? 2. Okay, good. Yes. So now we can move on. So this one use Pythagoras. Okay, yeah. So we have got the three lengths of the right angle triangle. Step 3 is to conclude. So what is sine B?
2/√3, and it will be positive.
Because we are in quadrant 3. So 2/√3. If you want, you can rationalize, it becomes 2√3/3. Same thing. Then how about the other angle? This is now part D.
Negative
tangent.
2.
Tangent B will be tangent beta, but what's the sign? Because we are in quadrant 2, so it's negative. Then it's negative of opposite over adjacent, 2/1, which is -2. Okay, good. Yes. You get it already. Okay, now you can try question 8 on your own, I think. Or should I, yeah, question 8. I'll just write down whatever you tell me. Okay, let's see. So, it's 11 already. Oh, okay, I knew. And maybe this will be the last question for the day.
Okay.
Okay, let's see how.
Okay, find out which quadrant. Wait, what am I doing? A. Okay, so it's negative in tangent, so it's either S or C, and then wait.
Oh, wait. Here is a bit different. Sorry. They didn't say that angle A and angle B are both in the same quadrant. So they could be in different quadrants. So let's try to figure out the interval first. Where is pi/2 and 3 pi/2?
Is S or T.
Okay, so it's over here, right? This region. Yes, S or T. So the angles are within this region. So let's look at the tan A equal -3/4 first. Tan A is negative, and it also has to be within this.
So means A
is in
quadrant 2. A is in quadrant 2, and then
quadrant
B
2.
is in quadrant 3.
Let me write down ASTC first. STC. What were you saying? A is in quadrant 2, is it?
Then B is in quadrant 3.
B is in quadrant 3 because it is a positive tangent. Yes, correct. Yeah. Very good. Okay. Yes. If there's only two possibilities, A can be in quadrant 2 or quadrant 3. Just check them one by one. If A is in quadrant 3, then tangent of A will be a positive value. But here we got negative. So that's a contradiction. So this is impossible. We cannot have the A to be in quadrant 3. By elimination, we only have one option left. It must be tangent 2. In quadrant 2. Let's just check. If it is in quadrant 2, tangent of an angle in quadrant 2, we know sine is positive, S is positive. Everything else, including tangent, will be negative. Does it tally with this guy, -3/4? Yes, it does. So therefore, quadrant 2. Same argument, and you conclude that B is in quadrant 3. Okay? Okay, so this is like two separate pieces of information. Then you can use that to solve for part A, part B, and then part C, part D. Do you want to try now?
Okay.
Can. Let's just do it. Step 1.
Take
Sine
alpha.
A. Sine alpha equals? Oh, sorry, tangent alpha, not the sine alpha, sorry. Tangent alpha equals +3/4. Step 2, draw the right angle triangle. So draw alpha. Where's my 3? Where's my 4? I draw. Okay, very good. 3, 4, and then this will be 5. Okay. 3 square plus 4 square gives you 25. Take the square root, you get 5. Now, step 2 is to do what? Step 2 is to draw already. Okay. Step 3, step 3 is to conclude. So you can answer part A and part B now. Part A is sine of capital A is just sine of alpha, but what's the sign? SIGN. Sine of the sign.
The sign is positive.
Yes, correct. So positive here. Then that means you get sine alpha, which is opposite over hypotenuse. 3/5, yeah? How about part B? Do the same thing. Cosine A will be
cosine A will be negative. Then 4/5.
yeah, 4/5 adjacent over hypotenuse. Okay, must remember it very well. Okay, so anyways, moving on to part B. Let's just finish up the question. Step 1.
Take the alpha.
I'll just use alpha because I'm more familiar with it. Equals to +2. Huh? Don't need to change sign. Step 2. Right angle triangle. Label alpha. Let me give you a hint. 2 is the same as 2/1. Can you label the length for me? Label,
Okay.
label. 2. And the last one is?
Wait, 5. Wait,
2 square plus 1 square. Then you take a square root.
root 5.
Square root 5. Huh? So that means you are done with step 2. We can move on to step 3. Finally, part C. Sorry, this is part C and D. Part C, you need to find sine B. So let me just, what is it? Sine B?
2/5.
So this is 2/5, is it? Wait a minute. B is in quadrant 3.
Negative sign.
Negative. So let me just write down the procedure. It should be negative, then sine of alpha. How do you know it's negative? Because of T here. Okay, because of T there. T means only tangent of a quadrant 3 angle is positive. Here we are taking sine of a quadrant 3 angle. So it must be a minus. So yeah, moving on to the last part. Finally, cosine B. What is it equal to? Negative 1/√3. Yes, because cosine is negative in quadrant 3. Okay, adjacent over hypotenuse. And we're done. Oh, 5, sorry, not 3. Okay. Should be a 5. Sorry, not 3. Then that was all for today. I'll send you your homework later.
Okay.
And bye-bye.
Okay, bye. Thanks.
Thank you.